Okay, so last year I broke this section at 7.5. This year I'm breaking at 7.4. We'll finish 7.3 today, and then 7.4 tomorrow. Both these lessons should go pretty nice. And I've given you, hopefully, what's a useful formula sheet. This sheet right here. On the last hour, they wanted to talk about a little bit about this formula sheet. I just want you to know that the boxes that I've kind of highlighted here, like we haven't really needed to use these boxes. That's from like a month and a half ago. But we're going to use these two today. We're going to use this one. Not today, but we have used this one. We've used this box, the half angles. We've used the power reducing. We've used double angles. We didn't use cofunction identities, not that big of a deal. We proved them. Even odd identities, we've used that. Sum and difference formulas, we've used that. Pythagorean identities, we've used that. Definition of six trig functions, we've used that. So, come test time, you got to make sure that you know which boxes to reference. And if the problem says convert from a product to a sum, then you know to go to the product to sum box. But suppose the problem looks like this. Find the exact value of sine of 75 degrees. It doesn't say use a sum and difference formula. It doesn't say use a double angle formula. Well, you could either do sine of 150 degrees over 2, or you could do sine of 135 degrees minus 60 degrees. So you'll have some choice, and it's being able to make that choice that's important. So you should be able to kind of look at the box and decide, well, do I know how to use that formula or not? If there's one formula you don't know how to use, you want to find that on the study guide and make sure that you know how to do it. So either tomorrow we'll do 7.4, or I'll do a kind of a cumulative review for you guys. Some small, short, quick quizzes in class to see, so you can assess exactly where you are. We'll see. All right, let's do the problems. Today we are going to go over really our last set of formulas, which is our sum to product formulas. These are useful in calculus, which is why this is called pre-calculus. And there's 8 formulas. We're just simply going to write down 2 of them. I just want to show you where to find them on your sheet. So this says write from a product to a sum. You can see it's product because it's multiplication. Take sine of an angle times cosine of an angle. And we're going to write it as a sum. So there's going to be addition in there. So sine of A times cosine of B. Which formula does that match as you look at your sheet? Does that match 1, 2, 3, or 4? 3, sine of A times cosine of B. So this is your formula. So you have to recognize that and then write it down. Like we have sine. I made a mistake every hour writing this down, so because I don't have the formula in front of me, so check to make sure I have it right. 1/2 times the sine of A plus B plus the sine of A minus B. Is that what the sheet says? Okay. So do you know how to find that formula? If you don't know how to find the formula on your sheet, then you won't be able to do the problem. Do I have it written down? Do I have it written in correctly? Okay. So then we have sine of A plus sine of B. So I look at my sheet and I try to find the sum. Where did my sheet go? There it is. Okay. So now I'm going to go sum to product. And is that formula 1, 2, 3, or 4? It's 1. So it looks like I have sine and I have cosine. So let me write this down. I think that's the right formula. Is that correct? And it says the rest are located on your sheet of formulas. So we're not going to write them down, all of them. I just want you to see where I found them and where I looked for them. Everybody good there? So now let's use our formulas. The problem is if you see this problem in calculus with an integral sign in front of it, it's very, very, very difficult to solve. But if we write it as a sum, then we can solve it. So that's why we're practicing it right now. So you see the transition. You won't be expected to remember this type of formula in calculus. You'll look at a sheet, but knowing the reference and how to use it will be important. So I have the sine of 4x times the cosine of 2x. So which formula do I use on that sheet? 1, 2, 3, or 4? It's 3. It's the same one that we wrote up above, so I'm going to write it down. 1/2 times the sine of a plus b plus the sine of a minus b. That's the form. So what is A? A is 4x. What's B? So now let's simplify. 1/2. Oh, got angry at me. One half times the sine of, what's a plus b? 6x. Plus the sine of, what's a minus b? 2x. Are sine of 6x and sine of 2x, are those like terms? No, they're not. So you can't combine them. So you would simply write this in the end as 1/2 sine of 6x plus 1/2 sine of 2x. Or if you'd like to write it as sine of 6x over 2 plus sine of 2x over 2, either way is fine. Those are the same expressions. Same expressions. That's it. That's all we're asking you to do. Next one, which formula? 1, 2, 3, or 4? 2? Cosine, cosine. Looks good. Can you read it off to me, Bryn? The 1/2 multiplies everything, right? So there we go, and then there's that 3 out front. That's really my problem. So instead of a 1/2, what's my coefficient out front going to be? 3x. A is x, b is 2x. What do I get? A minus b. Negative x. Plus cosine of a plus b. A lot of times we don't like to have a negative angle there. Okay, cosine of a negative angle. You should always simplify your answers so they don't have a negative angle. So cosine of a negative angle, we look at our sheet. Even odd identities. Cosine of a negative angle, what happens? It becomes positive. So I'm going to change that. 3/2 times cosine of a positive x plus 3/2 times the cosine of 3x. And that's it. Any questions how I did that? All right. Yep. So that's product to sum. Now we're going to do sum to product. Sum to product. You can see that these aren't written as sums, they're written as difference, but difference and, it's the same thing. Just subtraction with a negative. Or addition with a negative. So I got sine of 3x minus sine of x. So I look on my sheet, I try to find exactly what I have. Which formula is it? It's my second one, right? Sine of a minus sine of b. Looks like I have cosine then sine. So I'm going to write down the formula. 2 times the cosine of a plus b over 2 times the sine of a minus b over 2. What's a in the problem? A is 3x, b is x. So I'll have 2 times the cosine of, what's a plus b divided by 2? 2x. What's a minus b divided by 2? X. Done. So the whole key is just grabbing the right formula. Whatever a and b are, go from there. Which formula is this one going to follow? 1, 2, 3, or 4? Yep, 4. Looks like I have a negative on this one, negative 2. And it's sine and sine. So, got my formula, I write it down. A is 8x. A is 3x. What's a plus b divided by 2? 11 halves x, or 11x over 2. 5x over 2. Can I multiply those two signs together? I can't. Why? Why can't I? Why can't I? What makes it impossible to multiply those together? It's okay to divide by 2, but the problem is that they don't have the same angle. If they were both 11x over 2, let's say this was 11x over 2, then I would have sine squared of 11x over 2. Here's what some people do. They take the negative 2, they distribute it through. They get a sine of, say, we get a negative, and 2 times that, I'll just have 11x times sine of 5x. Can't do that. Totally illegal. Now let's see a sine times sine. It'll be like, oh, that's sine squared. And 11 times 5 is 55. And I'll have an x squared. Ooh, I got some squares. Let's square root it. You get like an imaginary number and sine of x roots of 55. That's voodoo hoodoo math. Can't do that. Don't do that. That stays like it is. It's done. That's it. So let's apply it. Let's put some real numbers in there, and we'll go to work. We want to find the exact value of these. Somebody said just plug it in your calculator. No, 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 no. You can't just do that on this test. You have to show all your work. And sometimes your calculator only gives you an approximation as opposed to the exact value. 3 times sine of 105 times sine of 15. Do you know what the exact value of sine of 105 is? I don't. How about sine of 15? I don't either. So let's try to write it as, instead of a product, a sum, and see what happens. This formula right here fits what I have right here for 1, doesn't it? 1/2 times the cosine minus the cosine. So let's write it down. 1/2 times the cosine. I think it's a minus b minus the cosine of a plus b Do I have that correct? So we made a mistake last hour. And then remember, we have the 3 in front of all that. So instead of a 1/2, we're going to have 3/2. What's A minus B? 90. What's A plus B? Do you know the exact value of the cosine of 90? 0. Find it on your sheet if you don't know it already. What's the exact value of cosine 120? Is cosine positive or negative in the second quadrant? It's negative in the second quadrant, so it's going to be minus a negative 1/2. Very good. Switches to positive. So I have 3/2 times 1/2. What's 3/2 times 1/2? 3 over. That's pretty nice. Any questions on that one? You have about 3 problems like that. And then I do the last one. Cosine of 45 minus cosine of 15. Do you know the exact value of cosine of 45? Root of 2 over 2. Do you know the exact value of cosine of 15? No. So let's try to write it instead of a sum. Let's write it as a product and see if maybe we can figure something out. That's a little bit quicker. So if you look at your sheet, you can see that you have cosine minus cosine. So it puts the fourth one. I have a negative in front, and it's sine times sine. So we'll write it out. Negative in front, 2 sine of A plus B divided by 2, sine of A minus B divided by 2. Is that the right formula? Okay. So A is 45, B is 15. I'm going to do A plus B divided by 2. What's A plus B over 2? 45 plus 15 is 60, over 2 is 30. Very good. What's A minus B divided by 2? 15. Do you know the exact value of sine of 30? Yeah. Do we know the exact value of sine of 15? So we didn't get rid of our total problem, did we? But we at least got this to be 1/2. Negative 2 times 1/2 times sine of 15. What is negative 2 times 1/2? Negative 1. So we've got negative sine of 15. We still got to come up with the exact value. What to do, what to do, what to do. What would you do on the test? Don't leave it like that. Ooh, Holly says she's going to use a sum and difference formula. What do you mean? Instead of sine of 15, you're going to do sine of... You can, but you need the exact value. You're going to do 45 minus 30. Okay, you could also do a half angle formula and do 30 divided by 2. So this is just my question here to you guys. This is where you would have choice on the test. If you have sine of 15, you either have to do, okay, a sum and difference, 45 minus 30, or you would have to do a half angle, sine of 30 over 2. Do you want to use the half angle or the sum and difference? It's up to you. First hour, the vote was 9 to 8 to use the half angle. Last hour, the vote was 8 to 7 to use the sum and difference. People are split. I know they're both really popular, so we're going to give the choice to Brent. Because you're the only one who's gotten a hole in one in this class. Has anybody else? Never had. Did you put like a magnet inside the cup and then like, inject? No, it wasn't. Okay. So Brent, which one do you want to use? You choose half angle or sum and difference. Okay, sum and difference. There we go. Let's use the sum and difference. It doesn't matter. Negative sine of 45 minus 30. That's how you're going to rewrite it, as a difference of two that we know. We know the sine of 45. We know the sine of 30. Well, that's the negative of sine of 45 times, do you know what comes next? Cosine of 30. Is it plus or minus? It's minus, exactly like it says. Cosine is where it switches. Cosine of 45 times the sine of 30. Now, there was a time where you were very good at using the sum and difference formulas, I'm guessing, right? That's going to come back to you before the test. Okay? So we're going to be okay. Negative, parentheses. What is sine of 45? Root of 2 over 2, cosine of 30. Root of 3 over 2, minus cosine of 45. Root of 2 over 2, that's where sine and cosine are the same, times sine of 30, a half. What do you get in the top? What do you get right here? Very good. Minus the root of 2 over 4. They have the same denominator. So that's negative root of 6 minus the root of 2 over 4. If you distribute your negative through, what happens to the square root of 6? It becomes, and the square root of 2 becomes positive. So this is the way I chose to write it. Some people really don't like that, and they would rather write as negative root of 6 plus the root of 2 over 4. It doesn't matter. They're the same. Freedom of choice. That's it. So obviously that last problem is a lot more involved, right? But the other ones are pretty straightforward. Give a formula, plug them in, give us the answer. You have 22 minutes to do that assignment.